the business is still, and I think that's a fair, sorry, Ryan, you'll probably have more to add there, but I think this is fair that it's a process gap, but it also causes data quality issues. So the data quality issue in that case would be the downtime of the pipeline or the schema change itself, depending on how you want to define the word issue. But in any case, like we mentioned before with that RACI model, the RACY model, or RACI model, it actually does come down to multiple people. In any case, hopping back to our quick exercise, when issues arise with the BI tool itself, you may also, this might also just be a semantic layer issue. So then it could be related to a schema change. It could be related to how you're defining that particular field within the business intelligence tool, within that dashboard, its reports. And in some cases too, another process error that can happen here is people being unaware of the definitions of particular fields or the usage of particular filters. In some cases, I've also had issues with joins where a stakeholder reported that a dashboard wasn't showing the amount of rows it was expected to show, and that was because of an issue with a particular inner join that I made. And if you have any other scenarios where this happens, if you have any other scenarios where these kind of things happen, please continue to pop them in chat. I can, if there's also something you want me to read out loud to everyone else, so that they're extra caution, so they have extra caution going into setting up a data stack, please do so, and I can read it out to everybody else as well. So the main takeaway here is that, and this is something that you all pointed out along the way too, so thank you all for that as well. But it's not just about tools at the end of the day. You can pick the best tool for every single use case, but even if you pick the best tool, even if they have some features to promote high data quality within your data platform, there's a human component as well to maintain steady flow of high quality data. That human component being more easily summed up with just keeping it in mind as you're picking different tools, which is why we included some of those data reliability considerations for each of those data storage layers, because that's where enforcing some of that recovery, disaster recovery, is more pertinent. But in any case, while you're picking tools, we have to consider how does that all work together and how will we actually enforce data quality monitors? Where do we need to enforce them? What types do we need to be aware of given historical mistakes, whether at that organization or another organization? And we've gone through that initial question of what are some of the contributing factors that lead to poor data quality at different stages of the data lifecycle. But a few of the other questions. What industries are particularly vulnerable to data downtime? Here is it depends on the use of the data. So for example, there are a few companies that are using any sort of third-party market research data to power just literally ad hoc business transactions on the fly. So the case in mind that I'm thinking about is the case where maybe there's a bank has a particular set of traders. They have an internal application where they decide or where they can see like the price of particular stocks. I'm not entirely sure. I'm not 100% a finance person, so I'm thinking this is what they deal with. But then they mentioned that they use the actual data within the internal application to make decisions to buy and sell on the fly. So in those cases where the use of data is pretty much real time, those are particularly vulnerable to data downtime because it's very likely that there's a lot of supporting processes to manipulate that data before people start making decisions with it. So finance is definitely one. The impact of data downtime is really big on healthcare as well, because healthcare, one of our most important industries, these are dealing with people's real lives here. So in some cases, it may be a little small difference, like, hey, maybe they're even like a particular patient's appointment time was moved back maybe 15 minutes. But in many cases, it could be even more stringent, for example, like in the case of mixed up medications or something like that. Software tech is also pretty vulnerable to data downtime just because it seems like tech has a higher propensity to adopt more different types of tools. And most surprising ways seen teams tackle data quality. Um, I think for the most surprising ways we've seen teams tackle data quality, it's I really the most surprising to me is anytime a team does any sort of manual process. Some of you all might have been tasked with this before, so apologies if I'm digging up old wounds. But one of the when I'm talking about manual processes, I'm talking about, hey, you have a calendar hold on your Monday mornings, 9 a.m. every single week to go and query a particular table and write out, like, let's say, like even something as simple as to select distinct count into a spreadsheet that your manager then checks. I think to me that's a very surprising way. There's always a better solution than manually querying something that, especially if it's as simple a query as that, and writing it out somewhere else. But then I understand at the same time, there might be some processes that are in the way of adopting a new, let's say, like automation, so that you can actually save some time doing that. And what are the common causes of data downtime in the modern data stack? A big common cause is actually not understanding how tools are functioning. So one case in point might just be like that data type formatting. We'll take that earlier example here. So a data source may export something in JSON format, but then, for example, let's say you don't actually know that object is going to be loaded by your tool or process in a JSON format. So when it comes to the actual warehouse, the query that you expected to work with that ideal table you had in mind, or even a test, maybe sample table that you're playing with, doesn't actually work. And you have to figure out how to unpack the JSON, unpack those layers into a suitable format. So that causes a lot of issues. Transformation tools, maybe not understanding correctly how to orchestrate them. That will also cause some issues as well if you have something downstream, like a business intelligence tool or a stakeholder is expecting data to be refreshed at X time each day. And that might lead to perception of data downtime as well. So that we are actually going to go to our second 5-minute break. In this 5-minute break, you can feel free to take time, relax, but at the same time, also feel free to type anything into chat that you want addressed or anything into Q&A as well. And I will go ahead and kiss off. Welcome back. And I will be passing it back off to Molly to talk about scaling data reliability.
Awesome.
As before, please mention anything you did over the break in the chat.
If you want to.
Yeah, the thoughts in the class is good too. Take it away, Molly.
Hopefully you weren't firefighting a data quality issue while you were on your break. Awesome. So thank you, Brandon, for walking us through that exercise. Super, super useful to see how data can break at each stage of the pipeline and kind of get a discussion going on things that you can do to actually stop it in its tracks beyond traditional testing, which as I mentioned earlier, we'll talk about during the next session. But today we're going to talk about how can we actually take data reliability and scale it across the pipeline so it's less tedious and manual. And before I dive in there, let's do a pop quiz. So what are some of the symptoms of data downtime? And feel free to share any others. And welcome CM back to the chat. Let's see what folks are saying. All right. All of the above. People have indigestion because of data quality issues or lose their metadata. Maybe. I've never had a data quality related indigestion, but who knows? Awesome. So, yep, a lot of these are symptoms of data downtime. Maybe indigestion is too. We'll see. That was a trick question. Okay, great. So kind of moving on to actually how can we scale reliability and quality. So for those of you from software engineering, I saw some of you in the poll earlier, noted that was your background in, which is awesome. We can really kind of start to understand ways that we can scale reliability and data by looking at our friends in software. So before I dig into what data observability is all about and what it might look like across your data pipeline, I want to pay tribute to someone who is near and dear to my heart, not just because I'm married to one, but they make sure that your favorite things like Slack and Netflix don't break. And if they do, that they're fixed before you can say Love is Blind, season 3 or season 4 or whatever season we're on. They're the person at your company or persons at your company who are responsible for building, maintaining, and fixing broken things at nearly every organization, and you may even be one. I'd like to thank the developer operations engineers, and more specifically, observability engineering engineers. We truly believe that solving this problem and stopping bad data in their tracks can be tackled by relying on some best practices from the software engineering world. For instance, software engineers leverage principles of site reliability and observability to ensure that their applications are performing as expected and that uptime is high while downtime is low. And so at the end of this course, we actually have a list of resources that we'll spend some time on and I'll walk through related to broader site reliability resources as well as some specific data reliability resources, but both of them can be quite useful, and we really can find some nuggets of wisdom in the processes and cultural aspects presented in some of the site reliability resources. But in any case, now is the time to apply these principles to data. So as organizations grow and the underlying tech stacks that support them become more complicated, for instance, moving from like a single data product to several, it's really important that we start applying some of these best practices at scale. And so in observability, in application observability specifically, it's broken down into 3 major pillars: metrics, traces, and logs. Metrics refer to numeric representations of the data measured over time, in this case, operational data. Logs are a record of an event that took place at a given timestamp and provide valuable context regarding when a specific event occurred. And traces represent causally related events in a distributed environment. So those are the three pillars of observability. And on the data side, we've noticed, and perhaps others would empathize with this, that approaches to data reliability and generally data engineering are about 10 years behind software engineering. In application development, every team has an observability solution like New Relic, Datadog, or PagerDuty to measure the health of applications and ensure reliability. And yet data teams so often are still flying blind. So what is data observability? Diving in here, data observability kind of refers to an organization's ability to fully understand the health of the data in their system, thereby eliminating data downtime to the point where stakeholders are no longer pinging you at 7 a.m. in the morning or 10 p.m. at night to fix a critical dashboard or data product. And other kind of associated issues. So we can kind of split up data observability into three different principles that I addressed, that I spoke to a little bit earlier when I was on the data quality versus reliability slide. But the first kind of principle is the ability to detect. You should be able to detect what is going on in your data at any point in time through kind of more automated approaches to anomaly detection, rule-based detection, so scaling your testing. I saw that someone in the chat mentioned Soda Core, which is awesome, but going beyond that and kind of really leaning into automation, knowing that data engineers cannot spend all of their time writing their own rules and scaling things and building things themselves. The second is targeted alerts to impacted owners and downstream users. So that those kind of really enable you to get started on the data observability lifecycle. Another one would be dedicated channels in Slack, in Microsoft Teams or email to surface alerts and begin incident management. So the second kind of principle here is resolve. So it's great to know about something, but you actually need to be able to resolve it to fix the issue and improve the reliability of your data. So kind of ways that we can resolve is through automated field level lineage, which we'll dive into in session 4 of the course, which kind of allows you to understand how all of the data assets in your system are connected. Second is kind of an impact radius assessment. And so what this means is like, okay, if data broke in this pipeline, who's using this pipeline? What dashboards is it creating? Who are the users that are affected? So understanding how data team or how downstream stakeholders are using data and what dashboards they're using, how often they're using it, how frequently, like what their kind of SLAs and stuff are for the data in the dashboard. Then that can kind of inform the way you might go about triaging issues. Third is kind of understanding the code, data, and operational diagnostics. So there are 3 ways that that data can break. Essentially, it's with your code, or with your data, and with kind of your operational environment. And so understanding how each of these fit together and impact one another, and ultimately help you find a root cause or several root causes, which is more often the case, the better. And third principle is prevention. So by prevention, as I mentioned, data will continue to break even if we have the most automated solutions. And that's just kind of a fact of life, like death and taxes. But ways that we can kind of make data more reliable is by auto-generating, on-demand insights about the health of your data. For instance, like how many monitors or data quality monitors are running on your data, so that if something does go wrong, you'll be alerted. What are the SLAs for that freshness or volume for a given dashboard? I know someone had mentioned measuring data quality KPIs, and Brandon will get into that a little bit later. Another one is kind of schema change notifications. So when a schema change happens, it doesn't mean that the data is broken. It just means that someone did something to the data. And so you should probably know about it to see if anything was affected. And then finally, automated circuit breakers. So let's say in certain cases, having bad data or inaccurate data is super detrimental to your business. So there are things called airflow circuit breakers that we'll actually talk about in a later session of the course. I believe it's session 2, where we'll talk through what an airflow circuit breaker is, and when to use circuit breaking, when not to use circuit breaking, and so on and so forth. And finally, I'm going to talk about the 5 pillars of data observability. So software observability has 3 pillars: metrics, logs, and traces. Data observability has its own set of things that you need to be monitoring and looking at to really understand the health of your data. So the first one here is freshness. Freshness seeks to understand how up-to-date your data tables are, as well as the cadence at which your tables are updated. Freshness is particularly important when it comes to decision-making, as we all know that stale data is basically synonymous with wasted time and money. And on the screen is an example of a freshness alert. Next is volume. It refers to the completeness of your data tables and offers insights into the health of your data sources. For instance, if 200 million rows suddenly turns into 1 million, you might have a problem, and you should probably know. And this can cause really serious implications. So for instance, if a customer churns and your data about it isn't updated into a revenue forecast, that's another issue. And then quality. So quality kind of refers to a function of your data's possible values. And it kind of tells you if your data is within an accepted range. It gives you insight into whether or not your tables can be trusted based on what's expected from your data. And so this is where you might want to get a little bit granular and kind of really dive into like the specific value distributions that you're looking for. And then next, we have schema. So I mentioned schema changes. The pesky schema changes essentially means the changes in the organization of your data. And when it happens, it can mean that the data is broken or someone pushed a change that wasn't expected. Again, schema changes happen every day in data pipelines, so it doesn't mean necessarily that something's broken, but if it's unexpected, it can signal something is afoot. And often they go silent or unnoticed because they are kind of caused by upstream stakeholders who might not be privy to everything else going on with the data. And so the final pillar here is lineage. So I mentioned lineage. We'll have like a deep dive session into it later. And it's really critical for root cause analysis, impact analysis, and kind of understanding how everything works under the hood. And so really excited for Zhuangzi and Pratik to kind of dive into how you can actually kind of build your own very kind of rudimentary lineage, but also the use cases for lineage and how field lineage works in practice, and actually how we built our own field lineage at Monte Carlo. So without further ado, I will pass it back to Brandon to talk a little bit about ways folks are currently tackling data reliability across kind of 3 of the main levers that folks take: testing, monitoring, and observability.
Thank you for that. As you probably noticed from the other slides about freshness, volume, schema, and quality, the types of issues that you typically run into are also interconnected. Like in some cases, a business stakeholder might point out, hey, this dashboard's wrong, this particular tile is wrong, this particular field is wrong. And your first thought might be jumping to, hey, is this a data quality metric issue? Like, are we feeding in the wrong inputs to ranges? Where in actuality, it might actually just be a freshness issue. Like the dashboard may not have been refreshed at the cadence as expected to. So when people are expecting to see the day's numbers, they might be noticing, hey, our total sum of all the revenue we generated is off. And it's not because that there's an input issue. There's a data pipeline process issue that leads to something like some sort of freshness incident. And then on the other hand, a volume incident may also be an indicator of a potential, let's say, source object issue upstream. Let's say in the case of a third party flat file upload, maybe they uploaded the wrong file for your particular company. So you might not be able to be processing the volume of data that you're historically used to. The idea being here that data quality issues tend to compound. But in the cases where your organization is small enough, so that is maybe you're at the stage where you're handling all analytics purely on a transactional databases, leading to potential less data quality issues in the process of let's say like ingestion into a data warehouse or lake, or transformations made in the warehouse or lake, because your use case is so small. Testing might be a good place to start off with. So this is where organizations will start off with. You may have experienced this yourself as well. Setting up a sanity check, let's say select distinct count rows on table A versus table B, just to make sure that in the process of the data cleanup query that you're running, you didn't lose any rows. And that might be a good place to start off with at first. But over time, what you're probably going to find is that as your data set grows, as the amount of data that you have to process grows as well, you're actually going to see a need for making sure that monitoring is set up on key tables, key fields that are maybe directly tied to a stakeholder downstream. So that might be one particular or one or a handful of particular model tables that sit directly before some BI tool processing data for a particular dashboard or report. It might be a handful of fields, maybe most directly linked to revenue, because you want to make sure that your reporting there is 100% accurate for the board meetings that happen every single week. In any case, monitoring is typically where teams will start to move into after doing some ad hoc testing for those sanity checks. It's a natural progression as well. But when it comes to having tens of tables that you're focusing on, and then hundreds of raw data tables, varied use cases downstream, then you want to start to consider an observability solution. And the distinction that we're making between observability versus monitoring here is the ability, you can see this in columns as well, to monitor your entire data storage. So we're not just talking about having that understanding of key tables and fields, because like we covered pretty in depth with the exercise earlier, covering only predefined tables and fields and doing sanity checks doesn't tend to scale out over an entire platform, because there are so many different ways. Every time data is moved point A to point B, that introduces the potential for a data quality issue to arise. And so with an observability solution, by monitoring all tables and fields and the interactions between those tables and fields, you're able to much more accurately capture the state of data quality within your data storage solution. And as part of that, capturing the data quality incidents is step one. From there, even if you have all the data quality incidents and no way to resolve them, no time to resolve them, then you're pretty much stuck and left at the same place of make sure there is going to be increased stakeholder trust by reporting it out to them, but decrease over time as you're not able to address those issues. And so an observability solution should also incorporate and consider troubleshooting along the way as well. By merit of troubleshooting and other features that may be available within the observability tool, you're going to be able to reduce time to resolution. You should be able to consider aspects of your troubleshooting, such as pointing out which tables that live upstream of something, like we mentioned with lineage, is actually responsible for any given incident that you may run into. Other troubleshooting processes that we've seen as well is also the ability to identify, for example, a recent query that might have led to a change or a data quality that you found downstream. But the main takeaway I want to point out here is that it's a natural progression to move from testing to monitoring to observability. And as an easy proxy for figuring out when you should move would be the amount of tables that you have, whether that's direct reporting tables, model tables, or total raw tables, where total raw tables is actually one of the nicer ways to evaluate, because higher amount of raw tables could indicate that there's a larger amount of use cases that will be generated over time. And again, like we mentioned, as you use data more and more and more, you'll probably run into more different types of data quality issues. Any anecdotes for any like early testing or stories that you all want to pop in, please do so in the chat or Q&A. And if it's in QA, I'll take it as a signal to read it out. In the meantime, while we're waiting for some of those to filter in, we'll talk about setting SLAs and SLOs. So as you kind of recall earlier, when going through application observability versus data observability, there are certain pillars that we can figure out how to repackage for purposes of data observability. One of those aspects of application observability that's been well defined in that area, but like Molly mentioned earlier, we're still kind of lagging to keep up with in the data world, is setting SLIs and SLOs. And you can see the definition here. The thing that we should keep in mind is when you're reading this definition, reading this slide to start off with, you are the solution and or vendor in this case, even if you're an internal coworker to your downstream stakeholder customers. But harkening back to application observability, we know that software engineers set service level agreements, those SLAs, and service level objectives, those SLOs, to track how reliable their software is. For example, using a framework such as 5 nines of availability, meaning that our service will only be down for maximum of 5 hours per time period. And if not, we'll waive the fees of our service for X amount of days to compensate. Some sort of agreement that makes sure that the vendor, aka you in this case, is delivering the services that are provided to reassure the stakeholder trust. And in many cases, that would be customer retention. But in your case, it'll be a combination of customer retention as well as just higher data adoption and higher trust to your organization, which is going to result in time savings for you as well. If you have higher data trust, you're also able to spend more time working on the projects that you were hired and excited to work for, rather than triaging people's questions and assuring them of any of their concerns. To monitor those SLAs and SLOs, you'll need to use different metrics to monitor software reliability. You may use a framework such as I've been using this word a lot, but it stands for utilization, saturation, and errors. While another framework such as RED stands for rates, errors, and durations. The idea here is getting engineering teams a good idea of how reliable their systems are and quantifying it based on downtime, how well equipment is being utilized, so that you can figure out how to improve system performance and application uptime. Similarly, data teams can also measure reliability by setting SLAs and SLOs for data and leveraging some new metrics to track data downtime. Traditional methods of measuring data reliability are often pretty time and resource intensive, but there is a different way to approach it that I'll talk through. Through this data downtime measurement that multiplies the number of incidents your team has. We can actually, skip to the wrong slide there. And we can see that in this form here. So it's a pretty, it's a pretty high level, like it looks like a pretty simplistic way of measuring data downtime. But there's a little bit of latency and decision making that you and your team will need to make when it comes to populating this equation for yourself. Excuse me. So, for example, number of incidents. This is something that your team has to agree on with business stakeholders. What classifies as an incident? Maybe you have some sort of severity ranking internally. I think like a P0 through P4 is a very common way to measure these things, with P0 typically being most important, highest business breaking issues versus like a P4 incident. And we don't want any incidents, just to set the conversation straight. But in the case that an incident does happen, you typically have to figure out this prioritization process to figure out what's your response rate when you're setting those SLAs and SLOs. So the number of incidents here is a little bit flexible depending on how you want to gate what actually constitutes an incident in this particular formula. A little harder to measure could be time to detection. This could be a timestamp of when the initial ticket was actually filed, and that could be the detection detection end time or start time, depending on how you look at it. But more accurately should be when something actually started and occurred to begin with, and that's something that you can set up in your initial triage process. So there's a little bit of flexibility there as far as what time detection means. Is it personnel detection, or is it actual when incident actually occurred as like T0? So that's a little bit up to your team to define as well. If you can, you should try to move towards a model where in your incident workflows and your postmortems, you should be identifying when an issue actually occurred, so you can figure out how long-standing it could have been, and how that'll impact your resolution process. In the time to resolution here, this is usually pretty on par with number of incidents for ease of defining, but your time to resolution here could be your measure for time to detection minus the fixed time. Some teams also use that sort of ticket resolution time as measuring time to resolution. The main takeaway here is that these are all factors, number of incidents, the time to detection, time to resolution, that all factor into your data downtime. Where those cases of data downtime, the impact of data downtime will actually be pretty dependent on what projects or use cases that data is powering. The more automated something is, the more automated like the use of data is, the higher the impact of data downtime incidents. And we're going to hop through some more polls and questions. So you should see one more pop up. And I recognize there's the reality of on 24 is that there's a little bit of delay between when I push this out versus when I actually see the poll results. So in the meantime, I'll try to talk through this while I'm waiting for the polls to load up for everybody, for everyone to catch up, and actually have ample time to respond to this particular poll. So thinking back a little earlier, how does the organization apply good data hygiene? There's no wrong answers here. It depends on the maturity of organization. But let us see if ever we can get a few more results, and then I'll push through how people are doing it today. All right, I'm seeing some of these come in. And on my side, I'll be pushing it in about half a second. So different ways that people can approach data hygiene. Data monitoring, for sure. That's an approach that I would estimate the majority of mid-sized companies are in right now. Data testing, absolutely fine as well, depending on how many data sets you're directly responsible for. Custom SQL checks is an aspect of data testing, something we see as well. Manual validation, even if you deploy an observability tool, it's likely that somebody will request you to do it in any case. All these very fair approaches. I would be curious to hear, yes, okay, Molly typed this in as well, what other people are considering other, as not mentioned here. And I just want to, I know I'm in this capacity teaching the course, but I'm also trying to learn from you all too, to see what you all are doing day to day. Poll question number 2 that I'm delivering. What is an example of a data SLA? And you all can feel free to type in your processes as well. Like I think earlier somebody had mentioned the use of an Excel sheet, grading different maybe data sets or use cases or fidelity for a particular project, and using that as a proxy for that. And then maybe in that case, the SLA is one aspect of that, like high data quality. Any case, you see. Other from the previous poll could mean multiple answers or just education. I think sometimes we'll laugh at this, referring to it as user error. So this will pop up, that'll pop up too. In any case, I'm excited to go through some of these examples of data SLAs. Nice. It's true. These are all examples of data SLAs. There's different types of ways that you can all measure this. There's no right or wrong way. The rightest way is to actually figure out what is most relevant for your organization. How do you start? One of the questions is, how do you actually start implementing SLAs, SLOs, SLIs? I think the pedantic part of me is trying to figure out like what the difference is between an SLI versus anything else that y'all mentioned before. I think it's actually just starting small. One easy way to think about implementing SLAs and SLOs is that it doesn't need to be extremely formal to begin with. You all should agree on a few different measures. Freshness or like update time, when something should be updated, when someone's expecting it, is something that should be agreed upon between the data team and the data consumers. That's a very easy place to start off with, especially as a lot of business sources have like date last modified or approximate type timestamps. So that's one easy thing to start off with. And oftentimes, if you want to use that as the sort of like stone that first starts rolling down the hill before creating a large snowball, you can use that to start the conversation. Because at the end of the day, I can talk about all these different types and ways to measure SLAs and SLOs. But you'll need to actually agree with your business stakeholders on how to do that. Another way to measure it could be actually just volume changes to begin with. And volume changes, like we mentioned earlier, you can use that as a level of, what is it called? You can use that as a level of certainty that the source reference objects aren't changing, that your transformations are running as expected. You can start with those two to not drown the team. And usually isn't too hard to set up, but again, it depends on how many objects you have. So narrowing down the list of objects that you have, especially if you have a small team that's focused on building your own observability platform, is usually helpful too. But like we mentioned before, that takes us to that monitoring stage. From there, you should actually figure out like how you can push and promote into like one of the considerations for the data observability platform you're building is figuring out how you can expand that to the rest of your warehouse. Gotcha. Good context from Ryan. Thank you for that. The trackable metrics you need to formulate an SLO. So I would say that the things I was talking about for volume and freshness were a lot more of SLIs, where you can combine the two of those numbers, those uptimes, to figure out your SLO, and then also tie that to the business case, use case you're supporting. So we'll jump back into where we would have gone before the poll questions. So you all should be seeing in a slide now, observability at scale. What does good look like? And if you're not actually seeing that slide, it's probably I should have checked on earlier, then please pop it into the chat if any of this slide moving is not working as expected for you. So observability at scale. This, like we mentioned earlier, it's a tiered approach. While teams are pretty used to measuring concepts like uptime, we expect this to become more and more standard as data products are more and more critical to business operations and using features. But at each stage of this journey, and I'll talk about these different levels, you need to start with those operational muscle. So thinking back to what Molly was saying before, in the detect and resolve pillars of data observability, there needs to be some sort of workflow in place. But more importantly, there needs to be some amount or some particular skill sets of people that are in place. So that you can support that operational muscle of, hey, this is an example of a dashboard you can build out, how to actually build this dashboard and how to deliver on improving to the metrics that you show within your dashboard. Number two is establishing service levels. So here the idea is to go over the internal exercises of figuring out what are these SLAs, SLOs, SLIs that we're agreeing upon with our stakeholders. How are you raising that sort of data fluency so that they can kind of understand what how much operational muscle goes into establishing and maintaining those service levels is also pretty important. And then finally, number three, and this is kind of a pick your own adventure type of path, federate the standards. Standards here are, again, very dependent on what type of data product you're building. For example, if you're building something that requires a high level of system uptime, like that trading platform that I was mentioning before for stocks where people are constantly moving large amounts of money, then some of the standards you might want to federate there might be different than, for example, a dashboard that gets only checked once monthly before some particular meeting. And much more tactically, we can go into what feels different as far as data reliability goes, some of the deliverables you can do, and what are some of the impacts of that for each of these phases. I'm not necessarily going to go through every single one of these bullets. You can take a screenshot now or review the course materials following this presentation. But the idea is that over time, you're creating a clear process with reportable measurements to continue to build trust with your stakeholders, continue to have them adopt your data top products, continue also to have them drive business decisions and materially affect your business depending on what type of data product that you're creating. So again, that comes down to building your team to build and maintain data pipelines and those relationships with internal stakeholders. Establishing those SLAs, SLOs are also key to that. It doesn't need to be super formal to start off with. You can agree on a smaller scope to start with. But over time, you're trying to build a product that your users need. So whether that's a self-service data platform or adoption by, what is it called, like a data producer, you will start to federate those standards, start to actually document them. And writing, I know not all